What up, Sci Fam? It's your boy Nickel here, and today we're gonna learn about the scientific method. So, this is the way we're gonna organize our page. It's gonna have a title. The title needs to say the scientific method at the very top of your page. We're then going to define science. We're gonna look at the different things that really make science unique to being defined as science, and then we're going to create a graphic. It's going to take up a majority of your page. So just be prepared to keep the first part of your notes in the top third of your page, and then leave the bottom 2/3 of your page for this diagram here. All right, let's begin learning about the scientific method. So science is a human-derived thing. It is a human way of knowing the natural world. So there are some questions that science can't answer. Like, for example, it cannot answer anything about the supernatural world. Science is unable to actually come to conclusions about things that are not related to humans knowing the natural world. So when we ask questions about is God real, or other ideas about intelligent life on other planets, we can speculate, but there is no way for science to actually come up with a way of knowing for sure about the natural world, because all of those things are beyond the natural world, or they're supernatural. Now, science is built on skepticism, because if you don't believe something, you're going to probably want to conduct science in order to confirm that that is true or false. So being skeptical is actually a really good quality that enhances people's ability to do science. It's built on skepticism. It's also built on evidence, because you must have evidence to prove that your claim is accurate or correct or incorrect. So it's built on skepticism, evidence, and explanations. So it usually starts with skepticism because someone doesn't necessarily know if something is true or false. They collect evidence and try to see if it's true or false, and then they explain what they found from the evidence and state whether or not what they were thinking to begin with was true or false. Now, science uses investigations. And these investigations are used to make observations like how hot or cold something is, the color of something, how long something is, how one variable impacts another variable. They're looking and watching about how things in the natural world interact with one another. So they're making observations, and while they make those observations, they're also collecting data. And we need that data. We need to collect the data so that scientists have evidence to come up with their explanations about how the natural world works. All right, so the scientific method is a process that we're going to simplify, and it's much more complex than this simple drawing. But in order to show how science occurs, there is a bit of a framework, and it's a lot like the design model or design thinking. Like if you've ever wanted to create a cartoon character or design a coffee mug in art class and design some pottery. So we're going to make a wheel here. So I basically made a donut. This middle part is like the hole, it's an empty part, and the inner tube part, or the donut part, is where we're going to put the different steps of science. To show the difference, we're going to use a little like arrow piece here to show that there is one thing that leads into another. And we need to have a total of 1, 2, 3, 4, 5, 6 sections here. So let's see, now I have 2, 1, 2, 3, 4, 5, 6. Okay, so I now have 1, 2, 3, 4, 5, 6 sections to put the parts of the scientific method in here. Now there is no start and there is no finish because it actually is a cyclical process. Some people might actually start if they have a question like, how come every single time an apple falls from a tree, it hits the ground and it always falls down? Well, that could be a question that you might want to investigate. So a lot of science could start with a question. But usually that question comes from an observation. like watching the apple. So an observation typically triggers a question. Once you have a question, it's like, well, why does that happen, or how does that happen, or what happens when this does that? That question then allows us to come up with a guess. And in science, whenever we have a guess, we call this a hypothesis. And we'll talk more about what it means to come up with a hypothesis in our next science notebook video. But when you make an observation, scientists will then come up with a question, and then to test the question, they come up with a guess of what they think is going to happen. And so the hypothesis is that guess. Once they have a guess of what they think is going to happen, then they can conduct the investigation, or the experiment is what you could say. And when they're doing that experiment, they're collecting data and they're going to look at their results. So they do an investigation to gather results, and once they have results, then they can come up with some conclusions, because they can analyze the data and see how it reflects back on their question or their hypothesis. So this is just a simple framework of a wheel that shows how science can happen. Now, there are times that a scientist might start actually in the investigation part and then work backwards to make sure they have a hypothesis and then go ahead and move forward. So there's not necessarily a specific starting point, but you can see how one thing leads to another. Once you have conclusions, usually that means that you're looking at the world a little differently, and you start to notice new things, and you end up with new questions, come up with new hypotheses, do new investigations, collect new data, and come up with new results, find new conclusions, which makes you look at the world differently again, so you have new observations, and so on and so forth. Whew, okay. Now, something that does happen is that scientists are not always very accurate with their hypotheses and making their guesses. So sometimes when they actually get their results, there's a little branch off here, because the results actually cause them to have to kind of reanalyze what they thought was true. So sometimes the results don't actually, or scientists are unable to predict what the results are going to be. And when they collect the results, they realize that what they need to do is they need to actually revise and redo their hypothesis. So they're going to revise the hypothesis and go back and talk about how one thing impacts the other if the results do not confirm what their original hypothesis was. So if the results don't confirm the hypothesis, then the scientist has to take this little journey over here, revise the hypothesis, and jump back into the experiment at the hypothesis level. And once they have a new hypothesis that might be a more accurate hypothesis, a more accurate guess, then they can go through the investigation and look at the results again. And if the results match this time, they can continue on. But if they don't, then they take this detour and they keep coming back and they keep revising their hypothesis, go through the investigation, check the results. Results don't match. Okay, we got to go back to the hypothesis. Hypothesis, do the investigation, collect data, check your results. If they don't match, you revise the hypothesis, you come back. And so a lot of science happens in these steps here. And if you're lucky, then your hypothesis is accurate and you can go from your results into your conclusion. So this is the process of science, and we are going to go through this process here in our Unit 0 Intro to Science, as we are going to conduct our own investigation. So we're going to begin by making some observations, asking some questions, developing a hypothesis, and doing an investigation where we'll collect results, and then finally we will actually practice coming up with a scientific conclusion as well. All right, I'll catch you on the next video.